In this investigation preparation lesson, we're going to be investigating solving equations. When we're investigating solving equations, we're going to specifically look at the simultaneous equations. We're going to have a preparation lesson today, and then next lesson we'll do this kind of investigation but in one lesson. So this is to do with Alicia, and she's looking at the simultaneous equations. She wants to investigate different values for A and for B. For example, the first suggestion she's going to have a look at is A is 5 and B is 1. She then simultaneously solves these equations. This is nice and easy. All she does is equation 1 subtract equation 2, and you're going to clearly get x equals 4. So this is why we have x is equal to 4, and then if you substitute x is equal to 4 into this equation, we know that 4 plus minus 3 is going to give us 1. So this is why y is minus 3. So she simply solved these equations together. Then she's going to try another random pair of numbers for A and for B. This time she's going to choose 7 and 5. So she's going to replace this number 5 with 7 and this number 1 with 5. And then she's going to simultaneously solve again using the same method as before. So it says she needs to solve to get values of x and y for more pairs of values A and B to complete a table like this. So you need to continue this with random pairs of A and B. Keep doing this until you find a pattern. So the pattern is, how do you get to x and y just by doing some operations with A and B? So for example, you can get x by doing adding, subtracting, times and dividing of these numbers, and then you can get y by doing adding, subtracting, times and dividing of 2 of these 3 numbers. So you need to describe what you did as a rule or formula, preferably using algebra. So for example, if a plus b is x, you would just write a plus b equals x. Then you need to predict what x and y will be for a pair of values that you have not discovered. So you need to say, using this rule, let's guess what's going to happen for a is 10 and b is 9. You verify it by simultaneously solving, and then you use algebra to show why it will always work. At this point you may want to refer to the original simultaneous equation question. I'm not going to go into too much detail here, but this is very similar. This time we are changing A and B to be different numbers. So we're changing A to be 5 and B to be 3. And we get that if we simultaneously solve this, x is 1/2. Now some of you might be wondering, well, how do we simultaneously solve this equation? So let me show you on the Jamboard how we solve it. The main idea with this is we've got a fraction. So in order to simultaneously solve it, we need to rearrange the equation slightly. So when we rearrange the equation, we're going to end up having x on both sides of the equation, so that we are left with no more fractions. Pasting this image in here, you'll be able to see it shortly. So effectively, what I'm going to do is move the 3x plus y plus 1, so it's no longer a denominator, and we're going to times both sides by this, so it will be moved up here. That's because we're multiplying both sides by 3x plus 1. Then we're going to get the equation as follows: 5x equals 1 brackets 3x plus 1. And obviously the 5 and the 1 are based on the A and B values we've chosen, so these will change each time, and then we're just going to solve this. So we would expand the brackets, we'd get 5x is equal to 3x plus 1, because we've expanded these brackets, and then we solve this equation. So we're going to minus 3x on both sides, so we get 2x is equal to 1, and therefore x is equal to 1/2. Because to get x on its own, we need to remove or divide both sides by 2, so we get 1/2. Go going back to this investigation, you need to carry on, and it's very similar to section A, apart from this time we are dealing with an equation, a single equation, rather than a simultaneous equation. Good luck with this preparation. Please revise it before your real investigation exercise.